Okay, welcome back to trigonometry. We are going to be working on some complex numbers here. So the idea is we want to take negative 1.1 plus 0.89i raised to the sixth power. All right. So you're going to be afforded the formula for De Morgan's, or not De Morgan's, De Mauvier's law. Okay, so you're going to be given this. You don't have to memorize that formula. Okay, please don't. So the idea here is let's go ahead and graph this thing so we can see what we're looking at. Okay. So we're going to graph this on the real imaginary coordinate plane. So we're going to go negative 1.1 and up about 8.9. So we're looking at the polar form of this number looking like it's over here. Okay. So the first thing I want to do is figure out the modulus of this complex number or the absolute value. It's just as the distance between 0 and that number. So it looks like a triangle. We could get a hypotenuse for this right triangle here, right? And figure this thing out. So the modulus, or the absolute value of z, is going to, complex numbers are almost always called z, is going to be the square root of negative 1.1 squared. Don't forget that squaring a negative makes it positive, plus 0.89 squared. Don't square the I, okay? We're just looking at magnitudes here. And we're going to go ahead and take that and figure that out as a value like this. Okay. So we go ahead and we'll figure this thing out. So I want 1.1, let's go with 1.1 squared. Okay. Plus 0.89, squared. Nope, just squared, not the negative one squared. Okay, equals, and then we have that, and that's going to give me 2.0021. Okay, that makes sense. 2.0021. And then we have to take the square root of that number. All right, so here we go. And second function, this piece here, second function answer. So we're going to write this down to four decimal places. So I have 1.41, we'll say 1.415, 1.415. So this is equal to 1.415. All right. Now, we also have to figure out what is this angle that we have sitting here. All right. So we have an opposite and an adjacent. So we can say that we think that the tangent of this angle is equal to my opposite, which is 0.89 divided by adjacent, negative 1.1. Okay. This is going to give me an angle in the fourth quadrant. I don't want an angle in the fourth quadrant. This looks like the second quadrant. Okay, so the next thing we're going to do is figure out this angle. So I want the inverse tangent. We'll say theta is equal to the inverse tangent of this 0.89 divided by negative 1.1. Okay, and we'll just go ahead and figure that part out now. So let's see here. We have I'm going to go ahead, and we're allowed to do this in degrees, so I'm going to go ahead and check to make sure I'm in degree mode because that's a little bit easier to think in. Okay, enter. So we are in degrees, and we'll just figure that out right now. Okay, so I want the inverse tangent, there we go, of 0.89, okay, divided by 1.1. All right, and we're going to put a little negative in there. I forgot to do that. So let's go ahead and insert and put the negative sign in there. Okay. And let's hope we're crossing our fingers that it's all in there correctly. And we'll say enter. And I got a negative, see, I got a negative angle, a negative 38.976. Okay, we're going to call this, I think, for this case, we're going to call this negative 37.98. Okay, so this is negative 37.98 degrees. And again, we see that that is definitely in the fourth quadrant. We're going to add 180 degrees to this thing to put it in the second quadrant. Okay, so there we go. We have 141.02. So my theta is equal to 141.02 degrees. All right. Now we have our modulus. Okay, sitting right here, 1.415. This is the absolute value of z. This is my theta. All right. And in order to take this thing to the sixth power, I don't want you to multiply this thing out, like FOIL this thing out 6 times. Like that's insane. So I want you to be clever. So we're going to say that we have z to the 6 is equal to the absolute value of z to the 6 times cosine of n theta plus I sine theta. Okay, and we'll figure that out. So we're going to say this is going to be 1.415 raised to the sixth power times cosine of, what is it, sixth power? 6 times 141.02 plus I sine 6 times 141.02. Okay, and that's what I'm going to do next, is go ahead and just figure out what is 141.02 times 6. Okay, so we're going to say times 6, and it's going to be 846.144. We'll say 146, 846.144. 846.144. 846.144. Okay, just double checking my work here to see if I'm actually 144. Yeah, that's okay. That's good. So we're going to say we need the cosine of this number plus I sine of this number. And then we're going to multiply this by, and we'll go ahead and say we need 1.415 raised to, so where's my caret button? Right here. Raised to the sixth power, and we'll see about that. And that was 8.027. So 8.027. All right. And now all we have left to do here is run this stuff through the calculator and figure out what's going on with it. Okay. So we could say we have 8.067 times cosine of, so the calculator already knows. It doesn't have to worry about the actual angles. We'll just go ahead and do that. And we'll say, okay, that's negative 4.73. So negative 4.73 plus I, and then we have to go through and multiply this thing out again. Okay, so that's going to be, what is this? 8.027 times sine. Don't worry about putting the I in there. We'll put it in writing. We won't want the calculator to do that. And this is 840. No. Oh shoot. There. Okay, let's go ahead and start that again. So we have 8.027 times sine. And then we have the sine, and we have, this is 846.144. All right. And I end up getting 6.48. So I times 6.48. And that is our answer to this complex number raised to the sixth power without having to go back and FOIL it. So that's the answer I'm going to report as my value. You can write the I after that. It's fine. 6.48. We'll say I. Put it there. All right, and that's how you do a problem like that. So again, you do not have to have de Moivre's law memorized. I will write that one out for you. I think it's really neat, but the only time I ever used it was I used it in one more class after I learned this. I never needed it again. So you don't have to memorize that one. All right, thank you very much for watching, and I will see you in the next video. Take care.